Welcome to The Explainer. Today, we're cutting through the myths, the magic, and frankly, all the marketing of the guitar industry. Instead, we're taking a highly sophisticated, forensic approach to what actually makes a guitar sound world-class. Our mission today? It's all about engineering the perfect lead tone. We're not buying it, we're engineering it.
So here's the high-stakes dilemma we face. You look at a guy like Joe Bonamassa, right? He plays a rig that is essentially worth more than most people's houses. We're talking vintage Dumble overdrive specials, custom Marshall Jubilees, original Les Paul bursts. I mean, it is literally a $100,000 setup. But what if I told you that his signature violin lead tone actually doesn't come from the massive price tag of those amps?
That brings us to our core thesis for today, and it's pretty simple. We are replacing financial spending with sound engineering. That legendary, smooth, cello-like tone you hear from the absolute greats, it doesn't actually require a boutique amp builder. Believe it or not, it's sitting right there on the front of your instrument, just waiting for you to use it correctly. It's time we stop chasing tone with our wallets and start deconstructing it with acoustic reality.
Okay, to kick off our forensic breakdown, we really have to look at the physics of why a Dumble, or any high-end vintage amplifier, sounds so incredibly muscular and musical to our ears. And it all comes down to something called harmonic saturation. See, when a guitar string vibrates, you get the fundamental note, of course, but you also get harmonics. The best amps out there naturally compress your signal and add these even-order harmonics. Think of them as mathematical octaves floating right above the note you're playing. And the crucial thing here is that this doesn't make the note harsh at all. It thickens it. It gives it that rich, vocal, cello-like quality that just seems to sustain forever. Now, there is a totally stark acoustic contrast between that highly desired harmonic saturation and the thing that plagues most of us, that obnoxious digital fizz. When you push cheaper amps or even some digital models way too hard with bright pickups, those upper harmonics distort. But they don't distort musically. They turn into these jagged, high-frequency, triangular-shaped waveforms, and your brain literally interprets those triangular waves as a harsh, super-fatiguing shh noise that actually physically grates on your ears over time. We call that phenomenon slewing. That right there is the fizz that completely ruins a great lead tone.
The actual physics behind this are just brilliant. In a truly great amp, you've got this large modulating waveform, but riding on top of it are these tiny, smaller riding waveforms created by the complex vibrations of your strings. A harsh amp? Well, it just hard clips everything. It chops off the peaks completely flat, like a razor blade, which generates that horrible, fatiguing buzz we just talked about. But soft-limiting tube distortion naturally rounds off those peaks. It allows those delicate, complex riding waveforms to pass through without a hard cutoff, and that is exactly what prevents your tone from becoming thin, retaining all the lushness of the note.
So the big question, how do we actually achieve this soft, rounded waveform without dropping $100,000? Well, we can look to some highly clinical, very direct advice from Joe Bonamassa himself. When he was asked how players can get his tone on a budget, his answer was so pragmatic. He literally said, all you've got to do is turn the treble down. Turn the gain up and the treble down. And that's pretty much the sound. So the absolute crucial point here is the science of the tone rollback. When you roll off your guitar's tone knob, you aren't just making it muffled or muddy. Electronically speaking, the capacitor forms what's called a tuned circuit with the huge inductance of your guitar pickup. You are literally dropping a filter curtain right at the source. You're actively removing those harsh upper harmonics before they ever even have the chance to hit your overdrive pedal or your amplifier. You are effectively killing the bees, those nasty triangular waves we mentioned earlier, and leaving only the muscle to be amplified. All right, so we've established the physics of the tone. Now we're going to pivot to our home builder blueprint. I'm going to show you exactly how to engineer this exact same thing on whatever rig you currently own sitting at home. Step 1 is our fizz killer. All I want you to do is roll your guitar's tone knob back to about a 6 or a 7. Seriously, that's it. It sounds way too simple to be true, I know, but this is the foundational step for getting that smooth violin sound. Bonamassa is constantly riding his volume and tone knobs throughout a gig. If you leave your tone on 10 and try to EQ the fizz out later at the amp, it is way too late. Those harsh harmonics have already been generated and distorted. You've got to cut the high end right at the guitar. Moving on to step 2, the slapback depth. Look, we really want to avoid drowning our hard-earned tone in those muddy, super long reverb trails. Instead, try using a very short digital delay. Set it somewhere between 30 and 50 milliseconds and keep the feedback very low. You just want a single slap.
What this does acoustically is it simulates a massive reverberant room, but it does it without creating this giant wash of sound that just steps all over your notes. It instantly gives your single note runs a real three-dimensional thickness.
And finally, step 3 is the EQ architecture. Honestly, this is where most players get it totally wrong, mostly because they try to EQ with their eyes instead of their ears. So first up, to get that singing lead, you need to set your amp's mid-range up pretty high, around 7 or 8. This specifically targets the 400 Hz low mid-range, which is what gives you that thick, vocal-like sustain. Then you want to aggressively slash the treble down to around 3. This eliminates any of that lingering ice pick harshness. And lastly, keep your bass right down the middle at about 5. The goal here is to make the lead sing, not scream, and definitely not boom.
Now, you might be wondering, why does this specific EQ architecture actually matter so much? Well, it's because of the very unforgiving science of frequency masking. We have all been there, right? You're in your bedroom, you dial in this scooped bass-heavy, treble-peaked tone, and it sounds absolutely huge. But the second you sit down with a real drummer and a bass player, that tone instantly falls to pieces. Acoustically, the electric guitar lives in a very specific pocket, between 350 Hz and 2.5 kHz. If you boost the highs, you're just competing uselessly with the cymbals. If you boost the lows, you're picking a fight with the kick drum and the bass guitar. If you don't push those mid-frequencies, your tone is absolutely going to be eaten alive in a live mix.
Just consider the massive difference between a towering, custom boutique stack and your standard, everyday working-class combo amp. Obviously, the price gap is completely staggering, but by actively applying the acoustic science of a tone rollback, that short slapback delay we talked about, and dialing in a mid-heavy EQ architecture, you can actually bridge the financial gap between these two very different setups. You achieve what we call vocal sync, which is a tone that sits perfectly in the mix, sustaining beautifully without tearing the audience's heads right off.
So this leaves us with one final, pretty important question for you to consider the next time you plug in. Are you going to keep chasing tone with your wallet, constantly buying the next overdrive pedal or some boutique amp, just hoping for a little bit of magic? Or are you going to start engineering it with your mind, using the knobs already right there at your fingertips to command the physics of sound? The blueprint is yours now. Go experiment. Thanks so much for joining me on this explainer, and I'll catch you next time.